things come up. So ALV grids. ALV grids are a method of outputting tabular data or table data that is different than what we have done so far. And what this does is gives us an output that is a little bit more, if you will, attractive in its appearance. The idea here is that we have been outputting tables by putting headers at certain column locations and then aligning things underneath it, and that's great, but suppose we want to put output out in something that looks more like an Excel worksheet with columns and rows and other things of that sort. And we can do that using either an ALV list display or an ALV grid display. And so whichever of these we choose, it's going to use data from an internal table as the output in the body of the ALV grid or the ALV list. And we do this through the use of functions that are built into the SAP environment in the ABAP reuse library. So there's a lot of different functions that are in the ABAP library that we can make use of, and so we'll talk about these pretty quickly this morning. In fact, you will see that there's a whole bunch of different parameters that can be passed to these methods and that we can receive back from these methods, but only 2 of them are required. And so that's what we will place our focus on. There's T_out tab, which is an internal table that we pass to this for the sake of telling us what the guts of the table are. And then I_structure_name is the fields in the table that is set in what's called a field catalog. And I can either set this by passing the name of a dictionary object as a string if the entire set of table fields is to be displayed, particularly if this is coming from a database table, or I have to build this myself. So I can use the function builder, which is SE37, to review the documentation. And so let's go look at that real quick, and we're going to see some things this morning with this that we have not seen before. So transaction code SE37, you'll notice, is the function builder, and I've given you in your documentation 2 of these. We will start with the ALV list display. So I just type in here reuse ALV list display. I could have searched for that if I were so inclined. And if we display this, this will actually take us to the function builder. This is the actual code for this, but if we go out here and look at the documentation, which I got lost there for a second because I was expecting to see it here at the top, and it's because my screen is not as wide as normal. You'll notice function module documentation. If I click on that, this takes me to the documentation. This outputs a short list, either a single line or several lines. This module outputs an internal table with any structure as a formatted 1-line or multiple-line list. The principle, you pass an internal table with a set of output information. You pass it a structure with a general list layout details. You pass it a field catalog, which describes the field, so those are going to be the column header. And you could continue here. You'll notice there's a lot of parameters here, but I've told you that only 2 of them are required. But there are things in here like about how the scroll bar works and how it's going to be painted on the screen. And you can actually make these to be editable. All of that you can find out more about by drilling into the documentation for these parameters, or doing a Google search for ALV grids in ABAP, and you can find a lot of information about them. I just want to show you the basics of how we can incorporate these into our programs so that you'll be able to use them in the future should you elect to. So let's do this. We're going to write, and this is in your slides here, we're going to write a real basic basic program here where we're going to select star from SP fly into table, and we'll create the table on the fly at data flight table. Okay, and I'm going to, for the sake of this, omit the error handling here. We know how to do that at this point, so I'm just not going to write the code for that. And so now I want to take what I've just loaded into this internal table, and I want to output it by way of this ALV list display. Now, something we have not used this semester, was talked about in your book, I don't know if any of you have been using it, we've not talked about it in class, is the pattern builder. And it's right here in the top of our array of controls. If I click on pattern, you'll notice I can choose different things here that it will give me source code for. For example, if I did this, chose select star from, and put in S flight, and then check this off, it like asks me what do I want to select, and I could say price and plane type and cease occupancy, and then I copy that, and you'll notice it kind of helps me write my query. So we have the pattern builder here that can help us with a lot of things. I'm going to use the pattern builder to help us with the use of the ALV grid. So if I go in here to pattern, and these are all functions. So I want to call the function, and I gave you the name of it here a second ago, reuse underscore ALV underscore list underscore display is the first one we're going to use. So what happens, it's really nice, is I put that in there and I hit the check mark, and it puts into my code the code to call this function. So you'll notice it says call function, and it gives the name of the function. You put function names in single quotes, and then notice it's commented out a lot of optional parameters, but there's my tables T out tab that I told you had to be set, and then if we want the column headers, then we have to set I underscore structure name, and it is here on line 18. So let's just start with filling in the table right here. So my T out tab, my table is flight table, so I'll just come here, and my scroll bar just stopped working. So I'll come down here and I will put in the name of that table, FLT underscore table, and then we'll save this. Do a syntax check, everything's great. Activate this. And then run. And notice it says the field catalog wasn't found. So it's really kind of ironic. I told you there were two things that were required. In the pattern builder, it only actually seemed to indicate that one of them was required, but that's not the case, as we just saw. So we need to go back here and we need to adjust that. And so I had to set I had to pass it the internal table as T underscore out tab, and then I have to pass it the field catalog, and so that goes into I underscore structure name. So I need to uncomment this line so that I underscore structure name is there, and the structure name here, if I'm using a database table, I pass it the name of the database table in quotes, which is what's going on here, because my internal table is totally based on SP fly. And so not sure why I'm seeing that in, the reason why I'm seeing that in red is I also have to uncomment out exporting since I'm passing that in. And so if we watch now, I'll save this and activate it, and then we run this. I'm going to activate both of these things so I don't keep getting this to pop up. And we run this. There's my output. So what it has done is it's gone out to the database table and it has pulled in the metadata about the field names, and it has given me the output here for all of the different columns in this. This is called an ALV list display. Now, the other alternative is an ALV grid display. And so just for the sake of going back through this again, I'm going to show you this one as an alternative too. So I'm going to get rid of all that code I just typed in, and we'll go back, we'll go to the pattern builder, and we're going to call function. This is from the reuse library. So reuse ALV grid display. And I must have misspelled something wrong. Reuse ALV grid display. Very interesting. Oh, I think it's because I don't know why I did that. I typed it in quotation marks.
I wonder, I was like, why does it need the quotes in there?
Yeah, it didn't. Okay, so this is the grid display, reuse ALV grid display. And so there it pulls up the interface to this. And just like we did a second ago, I have to scroll down and give it the name of the table as the T_out tab, and that's FLT_table, FLT_table. And then I have to go up here and uncomment out exporting, and I have to pass it the I_structure name, because this is going to be the fields. And so here I put in here, this is spfly. I can also, for this one, I can give this a title. And so if I come out here and find, sometimes the hardest part of this is finding the field you want. I_grid title. I'll set that to be the title that I want this ALV grid to be, and so I'll call this just my flights. Okay, and so if we save this now and we activate this, this is what we get. So there's the My Flights table with all the different fields in it. You'll notice it's automatically given me scroll bars horizontally and vertically. And you'll notice all of this as well here at the top. I get all of this for free. Like I could click on Departure City and I could change the sort order. And all of that is now at the discretion of the user by virtue of my using this particular option. And you notice there's sort fields, there's the ability to introduce filters. For example, I could say, well, I only want to see the departure city of Rome, and then I go back out and it's going to change the table output. If you recall back to your playing of ERP Sim, there were a lot of reports that were shown to you in these kinds of tables, and this is how you do that. This is another way of creating output through the use of these. So on your PowerPoint slides, the two programs that we just ran, if you don't want to use the pattern builder, the pattern builder gives you a lot of parameters that are optional. If you don't want that clogging up your code, you could of course delete the optional things that you don't use, or once you get comfortable with these, you could just type in the parameter passing. And so here's the two that I just showed you here. Now inevitably the most complicated part of this, just because it's time consuming, is what about putting the field names at the top? So let's go back and let's run our program again so we can make sure that we know what we're talking about here. At the top of every column, there's these labels like we've done manually before. This is coming from what is called a field catalog. And a field catalog simply corresponds with the internal table and gives us the labels to put at the top of them. I can only do what I have done in this code, which is passing in the name of the database table, if I'm using the entire database table. Suppose I'm only pulling in a subset of the fields, or suppose I'm putting output out to the display that isn't coming from a database. Then I have to create my own field catalog. And it's not hard, it's just kind of a pain in the neck. So let me show you how you create your own field catalog. If you're not using all the fields from a dictionary structure, number one, you can't pass in I_structure name. Instead, what you have to do is you have to manually create a field catalog and set it as the parameter IT_fieldcat. So how do you create a field catalog? So here's the code for creating a field catalog. And like I said, it takes a lot of code. It's kind of a pain in the neck. You create a field cat, data field cat, type SLIS_T_fieldcat_ALV. So that's a data type from the ABAP dictionary. Then what you do is you create a line that's like a line of the field catalog. You know, this is fundamentally going to be an internal table. So what you've really done here is created an internal table and a work area. Well, then you have to fill up the cat line. And the first thing you have to do is you have to set cat line, the field col_pause, column position. And notice this for my first field, I set it to 1. So then I have the field name where you give it the name of the field in the database. So let's say you have a database field name or an internal table field name that is username. So this would be username. Then the next one, cat line, the tab name field, you set that to the internal table that you're using, that this is associated with. And then you cat line cell text _M, you set that to be your column label. So that's what's going to show up at the top. And then you append that to the field catalog. Now, if you have 8 columns, you're going to have this recur 8 times. The only thing about that you would not have over and over and over again is your table name. Your internal table name that this is based on isn't going to change. But you would have one of these for column 2, where you would say what the technical name for that field name is, and then you would come down and you would say this is the text you want displayed at the top of that column, and then you'd append that. And so if you had 8 columns, you would have to do this 8 times. So you're looking at probably close to 40 lines of code that you have to write just to create the field catalog. So like I said, it's kind of a pain in the neck, but then once you have this, you create this and you assign that field catalog to IT_fieldcat. So here's an example of a program that does what we were just describing. So in this example, I go out to SPFly and I just pull city from and city to. And I want to show where we have flights going from and flights going to. I pull that into an internal table called flight table. And now I have to create my field catalog. Data field cat type, this is exactly what was on the last slide, data cat line like. And so cat line for column 1, that field name is city from. You can see that in my query. This relates to the FLT_table. That's my internal table. What I want to show up at the top of that column is the text city_from, like you see here. And so let's append that to the field catalog. And then we do the same thing for column 2. Cat line call pause 2. The field name is city 2. The table name is FLT_table. And what I want to show up at the top is city 2. And then I append that to the field catalog. And then when I'm finally done building up my field catalog, now I can call my ALV grid display function again. I pass it the title, just like we did before. I pass it the field catalog, which is called fieldcat. You see that on the second line there. And then for my internal table to be used, I pass it FLT table. And that will in fact output a 2-field internal table. And let's show you what that does. by copying this code into our ABAP editor and running it. So I'll grab this. Pull this into here. Get rid of all this code. Paste this in. Hope that PowerPoint didn't put any weird characters in here, but if it did, we'll discover that in just a second. Okay. And so there we go. City from, city to. Notice I still have the same controls that we had previously. The user has a lot of ability here. They can actually even export this to Excel. They can send it to a word processing program. They can save it to their local machine. They can email it to people. I mean, you kind of get all of this for free by use of that ALV reuse library for creating output. Any questions about that? All right. Well, as I said a few moments ago, we had 2 topics left this semester, and ALV grids were topic 1 of 2, so that is done. So our last topic for the semester, which I'm starting to be optimistic that we may be able to wrap this up today to give you Wednesday for studying and wrapping up programs. But I will forewarn you, what we're about to talk about next may well be the most complicated thing we talk about this semester. And I put this little picture there. This is confusing. I will have to walk through this very slowly. I will encourage you to pay very, very close attention to what we're about to discuss, because we're going to talk about ABAP objects polymorphism. Okay? And so I'm going to move somewhat purposefully through this, but please do ask questions as we go along. This is something that you might, even if you are present here today, might find it useful to look at in the videos or such. And we're going to use as a resource here the document class and purchasing document class that we created previously. And so let me just remind us by putting this on the whiteboard here. We previously created a structure where we have a document that is a parent, and then document has a child called a purchasing document. And so we talked about inheritance, and we talked about their relationship, and so now we are going to extend that discussion to the topic of polymorphism. Now, I will forewarn you that as we're going through this, the dominant question you might have is, why should I care about this? And I will explain to you how this is really, really useful and powerful once we understand the principles. But this is pretty tricky, okay? Now, here's what I'm going to put some things on the whiteboard here. I probably should have drawn this a little bit smaller, so I'm going to erase this, and we'll just remember that relationship. What we have done in our programs to this point is, and let's look back at this program right here that we ran as a demo where we worked with documents and purchasing documents. And you can see that on line 81, I created a variable named doc1. Okay? I'm going to put that on the whiteboard here in green. Okay? That's a variable. Doc1 is a variable that is a type reference to a document. Okay? And then I create that object. And so what I've actually done here now is I have doc1, that's the variable, and it is associated with an object that is a type document. And so that's what's going on lines 86 and 87. All right, then we come down, and on line 90, I create a variable called doc2. I'm putting all my variable names in green. And it is a reference to an object of type document. And then I create, down on line 97, a data object called PO doc3. And it is associated with an object of type purchasing document. So all I have done here so far is create kind of a pictorial representation here. And what I'm going to do is I'm going to put underneath my variable names their type. So this is of type, and I'm going to abbreviate here RT for reference to document. The second one is a reference to a document. And the third one is a reference to a purchasing document. Okay? So this is the code that we have already written previously. So let's talk about what are called narrowing casts. A variable that is a reference to a superclass can be assigned a subclass object at runtime using a narrowing cast. All right, looking at my code here on the left, which of these variables, doc1, doc2, and or doc3, which of those is a reference to a superclass? Doc1 and doc2 are a reference to a superclass. My sentence says a variable that is a reference to a superclass can be assigned a subclass object at runtime using a narrowing cast. So what that's saying is, I could come back and say doc2 equals PO doc3. Because this is a variable that is a reference to a superclass, can be assigned a subclass object at runtime using, this is a narrowing cast. So what I have just done, and I like to use the terminology of a box, I have taken a purchasing document and put it into a document box. I have taken a child of document and put it into a document box. Or a more formal way to put that is exactly what you see there on the slide. A variable that is a reference to a superclass can be assigned a subclass object at runtime using a narrowing class. The reason why we can do this is because the subclass contains all the methods and attributes of the superclass. So all expected elements are present. So let me go over here to the whiteboard and let's draw just another hypothetical arrangement. Let's assume I have a parent class that has defined three methods, M1, M2, and M3. And it has a child. And what the child is electing to do is it's using M1 as it is, M2 as it is. It's going to redefine M3, so I'm going to put that in a different color. And then it adds M4 and M5, which it's allowed to do. Okay? So if you think about it, if I take this object and treat it like its parents, does this object have M1? Yes. Does this object have M2? Yes. Does this object have M3? By virtue of inheritance, everything that the parent has, the child has. So that's why I could take this child and put it in the parent box, and it works because the child has everything that the parent has. Now, if you start thinking ahead a little bit, you might realize, well, that probably means that if I put the parent in the child box, that's going to cause problems because the parent object doesn't know anything about M4 and M5. And that's where we're headed here. But for right now, the idea here is I can take a data object of a child and associate it with a reference variable of type parent in my program, and it will work because all of the expected elements are present. This data object can access the methods and attributes that are available in the subclass through inheritance, because like just what I said, it knows about all the attributes and all the methods of the parent because it got those through inheritance. If a method has been redefined, the redefined version is used. Okay, so this is where this gets kind of fun and interesting and a little bit tricky. Let's go back to our code here. Let's run this first of all so that we can remember what this used to do. This used to display 3 documents on the screen. And remember, the document class just has 4 lines associated with it, whereas a PO document has 6 attributes associated with it. And we're writing these to the screen through calling the method display document. All right, so I'm going to come down here, and we're going to add some new code here. We're going to leave everything that was there before in place. And what I'm going to do is I'm going to put in 2 horizontal lines so that we can see the new code that we're writing here. And what I'm going to do is I'm going to take the doc1 variable, and I'm going to assign PODoc3 to that. So this is exactly what I wrote here on the whiteboard, except instead of using doc2, I use doc1. So I'm going to assign a child to the parent reference variable. Now, here's where this is kind of mind-blowing for the first time. If I say doc1 display document, remember, when I display a normal document, I get 4 attributes. I redefined that method for displaying purchasing documents, so it gives me 6 lines of output. So let's see what happens when I now call display document on this data object that is of type pointing to the parent, but is in fact holding a child. And so let me activate this. And we run it, and we see that even though I have called this using a parent object, it gives me the method of the child. That is called polymorphism. And ABAP supports it in exactly the fashion that we have described here. When I put a child object in a parent box, and I call the method, I can only call the methods that the parent knows about, but when I do call those methods, if the method has been redefined by the child, I get the redefined version. I can only call those methods that the parent knows about. So if we go back over here to my diagram where we had the parent knows about M1, M2, and M3, the child has M1, M2, M3, M4, M5. If I put the child in a parent box, it can call M1, M2, and M3 only. Cannot call M4 and M5. And if it calls M3, it gets the redefined version of M3. Once again, this is called polymorphism, and this is how ABAP implements this. What is the value of this? Okay. So we're not going to write the code for this for the sake of time. But you have a homework program that's optional that we previously used to illustrate this, but I cut out the polymorphism example of this. Let's assume we have a parent object, which I'll call P, and then we have a child of that, which I'll call C1, and then that class has a child of it that I call C2. In my code, I can create an internal table of type P and put any of these guys in it. Because I can always put a child object in the box of its parent without doing any harm to that child. And so one of the real virtues of this is our ability to have collections, or more precisely in this case, our ability to have an internal table of parents that can actually hold parent objects or child objects. And the reason we can do it is because of how ABAP implements narrowing casts, how ABAP implements polymorphism. We still have this relationship to realize that if the parent only knows about M1, M2, and M3, that I can only call those methods. But if I call that for child 2, and child 2 has redefined M3, then I get the child 2 version of that particular method. And I put here method defined to take in a reference to superclass data object, subclass data object can be used, would be another example of that. Any questions about this so far? So let's look at our code again, just to make sure we understand what's going on here, because we just have one more part to add to this and we'll be done. If I look at lines 106 and 107, and if I got to purposely think about this, on line 106, on the left side of the equal sign is a data object that's a reference to a parent. On the right side of the equal sign is a data object that is a child. So I can assign a child to a parent without any problem at all. And then when I use that parent object reference variable to call a method, I get the child's redefined version of that method if the child has redefined it. That's what my diagrams on the whiteboard illustrate. That's what this code right here illustrates. Any questions about this? Yes, sir.
In a narrowing cast, is some of the child's data permanently lost?
No. All I have to do is reassign it back to something of the child type, and I get it back. It's basically just masked from access at this point. So you've given me a real nice transition, which is once I put a child object in the parent box, how do I get it back? Could I follow this up after this line of code and do this? Okay, I want my object back in a child container. Can I do PODoc3 equals doc1? Okay, if you think what I'm doing there, now I'm trying to put this back into the child object that it came from. And let's watch what happens when I try and do this. Save, and I'll do a syntax check, and I get an error message. And the error message I get is the type of doc1 cannot be converted to the type of PODoc3. So I can assign a child to a parent, but at least what we're seeing here on line 108, I can't do that going the other direction. So that's what the next slide actually talks about. How could I handle this? Well, what we just talked about was called a narrowing cast. The other direction would be called a widening cast. A variable that is a reference to a subclass can be assigned a superclass object at runtime with a widening cast. All right, so let's go back to this over here on the right. A variable that is a reference to a subclass. So which of these guys over here is a reference to a subclass? PODoc3. PODoc3 is a reference to the subclass. So a variable that is a reference to a subclass can be assigned a superclass object. So how do I put what document 1 is holding or document 2 is holding, how do I put that in PODoc3? I can do that by employing a widening cast. Now, we've already seen that it doesn't like me doing it like I'm showing you on line 108. That's invalid syntax. So how does this actually work? Typically, you're only going to use this in the case that Noah was asking about. Suppose I stuff a child in a parent box and now I want to get it back out. This is my way of kind of undoing or inverting that. And so my syntax here is this. I move the superclass, and this is the funniest operator I've seen in any programming language. Because to me it's like the syntax is asking you, hey, do you know what you're doing here? Because this is a pretty rare thing. So this is not a typo. The operator is (2). Okay, so I do this using move superclass (2) subclass. So if I go back to my code, and I'm trying to put doc1 into PO doc3, so I would do move doc1 (2) PO doc3. And if we save and do a syntax check on this, we're going to find that is just fine and dandy. And now I'll put in another underline here. And now if I do doc1 display document, and activate it, we're going to find that works just fine, and all 6 of my attributes were still intact, even though I had stuffed it temporarily into a data object of type parent. All right, now, here's where this gets particularly tricky, and so I'm going to try and draw a picture of this that will hopefully make the sense of this. I have a parent object called document, which we're going to illustrate by, assume this is like a crate. Okay, this is a 3-dimensional object, this is a crate. And I am putting into it, here on line 106, I'm putting a PO document in here. Okay, so I just put PO document in the document crate. But as is illustrated by what happens on line 107, even though this is in the document crate, the system still recognizes that this is a PO document. So this is fine and good. And if I then pull this out of the crate, the system is still going to say, oh, you're a purchasing document. It never kind of lost sight of that, even when I put it in another box. So what about this scenario? Suppose I have a box of type purchasing document. And suppose I put a document in there. And remember, document is the parent. Okay? That's what I'm doing on line, well, it seems like that's what I'm doing on line 109. But we know that what I actually did on line 109 is what we're talking about over here. I'm pulling what was a purchasing document out of there and reconstituting it back as a purchasing document. But what happens if I take an object that was a document and stuff it into a purchasing document box? So look at this scenario. I'm trying to take this guy here and put him in a box of this type. Now, that's what I did on line 109. And it let me do that because it understood that what I really was doing was pulling a purchasing document out and reconstituting it. But suppose I put a plain old document in there using the syntax that we're showing here, what's going to happen there? So let's look at this, and what I'm going to do is I'm going to delete some of the previous code here for the sake of clarity. And so we're going to get rid of all of this we did right here. And so now we're back to what we see on the right side of the whiteboard here. Doc 1 is a regular old document. Doc 2 is a purchasing document. Doc 3 is a purchasing document. So suppose I did this. Suppose I did, and I want to put this into a child. So we said if I try this, Doc 2 equals Doc 1. To put a child into a parent box, if I try this and do a syntax check on it, okay, it's going to take that. Oh, I got to activate it. And so there's the scenario that we have been working with here. And so now I'm going to take a this gets very confusing really quickly here. Doc 1 equals Doc 2 put in my underline. All right, so notice something that just happened here. Doc 2 is a we've just been flipping and flapping back and forth document 1 and document 2, which are regular old documents. All right, so now what happens if I were to say Doc 3 equals Doc 1 equals Doc 3? So now what am I doing? I'm taking a regular old document and putting it into a purchasing document box. What's going to happen then if I try and call display document on document 3? We'll get rid of this line. So what's going to happen here? Who can tell me what's going to happen here? What's that?
Is it a widening?
Well, I'm less concerned with you knowing whether it's a widening cast or a narrowing cast as far as terminology goes. What kind of object am I trying to put into what kind of object?
A child and a parent.
Okay, I am trying to put a Doc 1, which is a parent. I'm trying to put a parent into a child box. And I can't do that, remember? Okay, wait, Doc 3 is unknown. Ah, thank you. That's just a typo. Is the reason why that's doing that. All right, so here's the error message I was expecting. The type of Doc 1 cannot be converted to the type of PO Doc 3. This is what we were saying before. I cannot put a parent into a child using the equal sign. I have to do it with move to. And so this is where I do move Doc 1 question mark 2 PO Doc 3. Now, the question is, does every object that we have created in this program knows about the display doc method? Let's try and activate this, and you'll notice it activates just fine. So what's going to happen now when I run this? I get this. I get a runtime error. And once we understand why this is, we're pretty much done with polymorphism. So the question is, I'm going to give you a second to think about this, and I want to see who can explain to us why this program just crashed when it got to line number 108.
Because it doesn't know what to do with M4 and M5.
Exactly right. When I put, if we go back here to this diagram, if I take a child and put it in the parent box, I've created a whole bunch of confusion because this doesn't know what to do with all of this extra stuff. So it is not at all a problem for me to put a child into a parent box, which is one reason, by the way, in UML notation, the arrows flow the way they do. I can take a child and put it into a parent, but it doesn't go the opposite direction. And so that's what this code that we wrote here was just illustrating. Even though it will let me do line 107, when I try and do anything with it, with that object, it crashes. So you might be wondering, well, what is the virtue of move $2? And once again, the odd syntax points to the fact that this is something that we very rarely do. And the only reason we have that statement is, here's a child. If I put the child into a parent object, no problem there. But what I then want to do is I want to move it back from being the parent back to being a child object. Now, since it started out a child, it's not a problem for me to copy a child to a parent and then a parent to the child. And so this right here is just done with an equal sign. This right here is done with the move $2 operator. Where I get into problems is when I try and take something that was always a parent and try and copy it to a child using move to. No good. Can't do that. But if I want to take something that was a child and turn it back into a child, that's what I use the move $2 operator to take care of.
Is that so you can do data hiding? No.
Well, the fundamental reason for polymorphism is what I was talking about before. I could create a table, database table or internal table of parent and put children in it and then traverse the table and say, you know, display document. And it will call the appropriate method depending upon what the underlying type is of it, because it's all been put into a parent box. So it's the way ABAP manages containers of types in a hierarchical situation. I go back to this slide right here. I mean, this is like the trickiest thing we will talk about all semester. But fundamentally, you know, this slide right here summarizes it. If I have on the left side, those are variables. On the right side, those are actual objects. And in the picture in the center, we see where I'm trying to assign a PO document, which is a child, and I'm assigning that to a parent. That's called a narrowing cast. When the document reference is used to refer to this object, I can only use the methods and attributes that are defined for document, so I lose some abilities. I have a narrower set of abilities. That's why this is called a narrowing cast. The bottom picture, I'm taking on the left side of the equal sign, that's a child object, and I'm putting a parent object into it. When PO document reference is used to refer to this document, I can use methods and attributes defined for PO documents. I have wider ability. However, I can only do this if the object I'm assigned to is actually a PO document that was formally cast into a document using a narrowing cast. This is another way of saying what I drew here on the whiteboard with this set of pictures right here. And so let's revisit this again. If I turn child into a parent using just an equal sign for assignment, I could turn it back into a child using the move to statement. But if it started out a parent and I take a parent object and try and move it to a child, I've just created a recipe for a headache. That kind of widening cast is likely going to result in my program crashing at runtime. And the only time I ever have to resort to using any of this is exactly what I said there with if I want to create an internal table and put data objects of varying types in it. I base the internal table on the parent, and then I could put parent objects and child objects in there without any difficulty at all. Questions?
Do you have to do the, if you've done a narrowing cast of a child to a parent, and then you want to include more information, will it automatically retype it to a widening cast, or do you have to explicitly call it?
You're going to have to cast it back using a widening cast. If I do a narrowing cast, if I do this over here, where basically I put the child into the parent's box, I can only call methods 1, 2, and 3. And we didn't make any reference to attributes, but maybe there's attribute 1, 2, and 3, and then there's attribute 4 and 5 that I've added. When I put it in this box, I only get to call method 1, 2, and 3 and reference attributes 1, 2, and 3. If I want method 4 and 5, or I want attribute 4 and 5, I'm going to have to turn it back into a child in order to do that. Other questions?
I'm having a hard time seeing when you would use this in like the real world,
It's the only case I can tell you.
like an internal.
If you think about now, there's an optional program where I have you create train cars. And what that assignment used to ask students to do was create train cars of the different types, and then create an internal table based on the parent, and then just append all of those objects to that table, and it works just fine. And then you can traverse the table using a loop at statement and call the, I forget what it, there's like a show info or something. And if you call show info as you traverse the table, it will call the appropriate method. So if, in this case, if it's a parent object, it'll call this M3. If it's a child object, it'll call this M3. And I think in that hierarchy you had another child. If it had a different M3, it would call that child's M3. So the system knows which version of M3 to call based on the base class of the object. And that precisely is what polymorphism is. And this is the only case, I mean, this is not something you're going to break out in every program you write by any means at all. It just has a very, very specialized use case, which is why we're covering it here at the end. I want you to be familiar with the concept, but I'm actually not having you write a program on this due to the sake of time. Other questions?
I have one question.
Yes.
Like the parent to child, where you can't do it that way, would there be like a way you could make it like a workaround, like it would create it, but like have a method within the parent class that would make it a child class?
I don't think there is any way you can get there from where you start. I don't think so. Because it has to do with just the way the system manages the attributes and methods of the child versus the parent. So it's kind of like, if you will, if you drink coffee and you're familiar with freeze-dried coffee, it's like they start with coffee, they freeze-dry it, and then you add water to turn it back into coffee. That's kind of what we're doing right here. This is like we're taking a child and we're freeze-drying it into a parent, and then we're adding water to it to turn it back into a child. Although I'm not advocating freeze-drying of children, just to be clear. On the other hand, this was never coffee to begin with. So, we're reconstituting something that didn't start out as coffee, so who knows what you're getting here. So this just gives us a way of kind of reconstituting something that was stuffed into another kind of box.
Could you
previously.
copy the values from the parent and then like have the add the like M4 and M5 to the child so that you can make basically a copy of the parent.
Oh, you can
child
copy.
format,
You can absolutely copy it. You know,
and
that's
then you could shove it in.
if it starts out as one kind and if you want to reconstitute it back into what it was, you absolutely can do that with a widening cast. That's what it does. This is kind of the equivalent of adding water to freeze-dried coffee. This lets us turn something back into what it used to be. Okay? Questions? Well, as I mentioned at the outset, for those of you that were here, these were our last two topics for this semester. So in light of that, we will not meet on Wednesday. I will give you that time to work on your remaining homework assignments, to get ready for your final exam. Your final exam for this class is it next Wednesday?
Yes.
Yeah, next Wednesday. So you have about 9 days to get ready for that. If you have not yet signed up for your testing time, I would encourage you to go do that right away, because during exam week, the testing center gets very full, and so you may not get your preferred time, particularly if you haven't signed up yet. So in D2L, there's an announcement there with a link to the testing center website. Between now and next Wednesday, if you have any questions, please feel free to come by my office or email me. For those of you that this was your third class in the SAP sequence and you have a certificate coming, I emailed you about that. I prepared those certificates. What I'll do is wait till after you take the test on Wednesday, make sure everything's good, and then I'll email you and you can come by and pick up the certificate. Or if you won't be on campus after that, if you'll let me know your mailing address, I'll be glad to mail the certificate to you. So I want to make sure everybody gets that. If for some reason this is your third class but you don't know what I'm talking about, check through your email, because I emailed everybody about the certificate so as to have that prepared for everyone. Last call for questions before we head out. Anything? Yes, sir.
So on the final exam is just basically what we had on the midterm and the stuff that's coming up in what we discussed. You know what I'm saying? Like for the
Things from the first half of the semester will be things that you have seen on the midterm exam.
Okay.
And then things that you haven't seen before will be things from the second half of the semester.
Okay, just want to clarify that.
Mm-hmm.
Thank you.
Absolutely. All right, well, have a good afternoon, everyone, and see you around campus.